So in this video, I'm going to show you about the Michaelis-Menten equation, how it is derived and what exactly the enzyme kinetic is. So the enzyme kinetics is the study of the chemical reactions where the enzymes are catalyzing the reaction, and the reaction by which we can know the rate of the reaction, and also different kind of varying factors can be investigated. Okay, so this is about the enzyme kinetics. So before going to the detailed process how the equation Michaelis-Menten equation is and how it is derived, let me tell you the enzymes definition. Enzymes are the biological catalyst that can induce or that can increase the rate of the reaction by lowering down the activation energy, and also after the formation of the product, which is the conversion form of the substrate. So after the formation of the product, the enzymes structure and conformation is not changed. These things are not changed, it remains constant. So basically what happens, I have already drawn one particular graph to understand what is going on here. So this is the y-axis is indicating the relative concentration, and the x-axis is indicating the time, the rate. Now if suppose here we have added the substrate and also the enzyme So as we know, in the catalytic reaction, or if any kind of reaction is going on in the presence of enzyme, it will actually reduce the concentration of the substrate. So that is what the blue graph is showing, or blue line is showing here. During the process, the substrate concentration is reduced with time, and the product formation is increased with time. But the transient state, which is the enzyme substrate complex, that is the intermediate transient state or transitional stage of the enzyme, the product formation is here, this green line. Now here if we say that if this kind of graph is showing the steady state of the reaction, that means it indicates the rate of the formation of the enzyme substrate complex and the rate of the dissociation of the enzyme and substrate complex is equal. Okay, so here let me write it here again. The rate of formation of enzyme substrate complex is equal to rate of dissociation of the enzyme substrate complex. Okay, so mathematically we can express this thing like this. B is the molar concentration or the concentration of enzyme and substrate together divided by time, that is indicating the rate of the reaction, is equal to 0. Okay, so with this equation we can say that this particular no changes are there in the reaction. Okay, because the rate at which the substrate and enzyme complex is produced, okay, the rate at which the substrate enzyme is produced and the rate at which the enzyme substrate is dissociated, substrates are dissociated, are same. Okay, so with this equation we can write this enzyme catalysis reaction like this. So this is the enzyme and substrate, this is the forward and backward reaction. It will make the enzyme substrate complex that is actually activated from, then it will produce the product and release the enzyme. Okay, now if we look at the rate of the reactions, now if this is the forward reaction which is making the enzyme substrate complex, that is denoted as K1, lowercase k1, and the backward reaction is indicated by lowercase k minus 1. and here in this direction also the enzyme is also dissociated. Here the product is formed and the rate of this reaction is K2. Okay, so if we from this point, if we go in this direction and if we go in this direction, in both the side or both the direction, we are actually dissociating the enzyme substrate complex. In this side we are actually dissociating the enzyme substrate complex into the enzyme and substrate separately, and in this side we are going to produce the or breaking down the enzyme substrate complex into into the product and the enzyme. Now if we look at the rate of the reaction of the formation of this substrate enzyme substrate complex, then we can write it like that: K1 into the concentration of enzyme and the concentration of the substrate is equal to the rate of dissociation, because we will see the rate of this thing and the rate of this particular reaction. Okay, these two kind of reactions are put here. K minus 1 is equal to into the enzyme substrate concentration plus K2 into enzyme substrate concentration, because this side, this rate and this particular rate, these two rates are indicating the rate of dissociation of substrate enzyme complex or enzyme substrate complex. Now from here we can see that this is the enzyme and this is the substrate concentration. Here what will be happen? In any kind of reaction we know the concentration of the enzyme and also we know the concentration of the substrate, but at a particular given time, after certain time period of time, what will be happen? This out of the total amount of enzyme, some enzymes are free and some enzymes will be involved with the formation of enzyme and substrate complex. So let's see. Suppose this is the concentration of total enzyme, and it means the total enzyme is equal to the free enzyme plus enzyme substrate complex, because this amount of enzymes are not free, these are involved with the formation of enzyme substrate complex. And if we see the if we look at the particular E, so E is equal to minus concentration of P's together. So in the place of E here we can write this particular equation, right? So K1 within first bracket the concentration of total minus the enzyme substrate complex. Now here the S will come, and from this equation we can take the enzyme substrate complex as a common thing. Okay, if we take the enzyme substrate as a common, then we will left up with K1 minus 1 plus K2. Now we will add this substrate concentration with both the things, with this one and with this one also. So let's see what is the equation after that. And in this side the remaining it will be same as it is. Enzyme substrate complex and K minus 1 plus K2. Okay, so from here in the true side we can divide with K1. Two sides, if we add or if we divide these two sides into with K1, so it will end up with this reaction. K1. Okay. Now this K1 and this K1 will be removed. Okay, and so we will end up with this equation, and here this particular thing is known as K minus 1 is equal to Km. This Km is called the Michaelis-Menten equation, Michaelis equation. Michaelis equilibrium and constant, Michaelis constant. This is the Michaelis constant. So in the place of this particular K minus 1 plus K2 by K1, we can write the Km. Okay, so this is the Michaelis constant. So here again we come back to that particular region. Now what we will do, we will just put this particular thing on that side. Okay, this particular equation on that side. So let me check it once. Yeah, we have to shift this particular equation in that side, right side. So we will end up with this, okay, and is equal to enzyme substrate into Km plus enzyme substrate complex and the concentration of the substrate. Now here we can take these two enzyme substrate complex as a common. So I am taking this ES, enzyme substrate complex as a common, Km plus S. So this will remain separate. Okay. Now if we add this Km on both the side, Km plus S concentration S on both the side, then we will have this equation. Divided by Km plus concentration of substrate, and here enzyme substrate complex, Km plus enzyme only the substrate concentration divided by Km plus substrate concentration. So these two particular equations are removed. Now we will end up with this SES. So I'm just writing this equation in reverse, okay, in direction, is equal to Okay, now let me tell you one thing, that from this equation we have to change something in the equation, not in the system. So previously, if you look at the initial velocity will be Vi, that is the initial velocity, is equal to enzyme substrate complex into the K2, because this is not indicating the initial velocity. Initial velocity of the reaction is indicating only this one, this two, only this one, when the product when the substrate and enzyme is are produced. Now what will happen if we multiply this K2 this rate, because it is not used, we are actually talking about only this particular thing, so this is not used. So if we multiply this this particular rate with the enzyme substrate complex, that will be the initial velocity, right? So I have written this here. So then we can derive the ES, or enzyme substrate concentration, like this, minus divided by K2. So we can put this equation over here. Okay, now so this is the initial velocity. Now what about the maximum velocity? So maximum velocity is, if we divide, if we take this as a Vmax, then if the initial velocity reaches its maximum velocity, then what will be happen? It will so no substrates are there in the system. Okay, all the substrates are converted into the product, so it will left up with Vmax is equal to, means all the enzymes are saturated. Okay, at the end of the reaction, or when the system reaches its maximum velocity, then all the enzymes are saturated. Here the rate for this product, because it is indicating the last or at the end of the reaction, when the reaction reaches its maximum velocity, K2 with the molar concentration of. So this particular thing is indicating the maximum velocity, means where the total amount of enzymes are actually used, are saturated. So we can put this particular ET value with this one. Sorry. Yeah. So if we bring this K2 with this particular equation, then the equation will be now here. If we look at that particular equation, then it is similar to the Vmax. Okay, so we can put the Vmax over here. Initial velocity is equal to Vmax into the concentration of this thing into Km plus S. Km plus S. Now this is the actual Michaelis-Menten equation. So this is how the equation is derived. So this is called the Michaelis-Menten equation. Michaelis-Menten equation. So from this equation we can also calculate, or we can also see the Km, what is the K meaning of Km. So suppose this is the initial velocity and this is the maximum velocity, and if we think about the half of the velocity, okay, the reaction velocity will be the half, and what will happen, the V max equal to, sorry, the Vi, or initial velocity will be the V max divided by 2. So here we can put this equation here. So the V max divided by 2 is equal to, because this is indicating the half velocity, okay, half of the velocity. Now this will be Vmax into S divided by Km plus, so your Vmax will be removed and it will end up with Km plus S is equal to 2S, and this bring this thing on this side, so Km is equal to that means the Km is actually denoting, it is indicating the concentration of the substrate by which the reaction can reach its half of the maximum velocity. Okay, so this is how the Michaelis-Menten equation is derived, and in the next video I will show you a it will be a very short video regarding to the graphical representation. In the graph, how can we plot, how can we understand the exact meaning of this Vmax and this Km. Okay, so this is all about the Michaelis-Menten equation and the enzyme kinetics, and if you like this video then please share it and subscribe my channel. So thank you.